Hi, in this video I'm going to show you how to calculate the HCF and LCM of numbers and also how to go and find the units place digit. So what is meant by a factor? Let's take a number 10. Now 10 is divisible by the numbers 1, 2, 5 and 10 itself. So 10 is the greatest factor for itself, and if I take another number, let us say 15, then 15 can be divided by 1, 3, 5 and 15. Now for both these numbers, the common factors include 1 and 5. So the highest common factor for both of them is 5. So HCF or GCD, the highest common factor or the greatest common divisor for the numbers 10 and 15 is the number 5. Similarly, if I take two numbers, let us say 18 and 24. Now 18 can be divided by 1 and 18, it can be divided by 2 and 9, it can be divided by 3 and 6. Similarly, 24 can be divided by 1 and 24, it can be divided by 2 and 12, it can be divided by 3 and 8, it can be divided by 4 and 6. Now, among all these things, the number 1 is common, the number 2 is common, the number 3 is common, the number 6 is common. So the highest common factor for both these numbers is the number 6, right? So going by this, let's try to identify what is meant by the highest common factors for a set of numbers. So for 12 and 18, 12 is prime factorized as 2 6 are, 2 3s are and 3 1s are. 18 can be factorized as 2 9s are, 3 3s are and 3 1s are. So here we have 2 as one of the factors, no 2 common, again 3 as one of the common factors. So the common factors for 12 and 18 is 6. Similarly, for 30 and 40, 30 can be factorized as 2 15s are, 3 5s are and 5 1s are. 40 can be factorized as 2 20s are, 2 10s are, 2 5s are and 5 1s are. The common factors are 2, no 3, no 2s and then another 5. So for 30 and 40, we can easily identify that the common factor, that is the highest common factor for both these numbers, is 10. Now the HCF of 144 and 216. For 144, we can factorize this as 2 72s are, 2 36s are, 2 18s are, 2 9s are, 3 3s are, and 3 1s are. For 216, we can identify 2 108s are, 2 54s are, 2 27s are, 3 9s are, 3 3s are, and 3 1s are. So the common factors are 2 multiplied by yet another 2. Again, we have a common 2, then this is not common. We have a 3, and again we have a 3. So 2 2s are 4, 4 2s are 8, 8 3s are 24, and 24 3s are, we get the common factor as 72. So can you pause the video and quickly calculate what should be the HCF of 60 and 120? Once you got the answer, come back to this video and check. I hope you have got the answer as 60. Okay. For 1250 and 1500, again you can calculate the answer and check. Your answer should be 250. So we use the same technique to identify the HCF of set of 3 numbers. So for 12, my factors are 2 6 are, 2 3s are, 3 1s are. For 16, 2 8s are, 2 4s are, 2 2s are, 2 1s are. For 18, 2 9s are, 3 3s are, and 3 1s are. We have a 2 which is common for all of them. The 2 here and here, but no 2 here, so cannot be taken. Then 3 here, but not here, so cannot be taken. So nothing is common. So the HCF is simply 2. Simply for 24, 32, and 48, you can calculate and your answer should be 8. So these are the highest common factors of numbers. Now, least common multiple. So let's take the number 2. So all the numbers which come in the table of 2, like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on. All these are called multiples of 2. Similarly, for 3, the table includes numbers of 3, 6, 9, 12, 15, 18, 21, and so on. Now, for both the numbers 2 and 3, certain numbers in the table are common, like 6 appears in both of them. Then we have the number 12, which appears in both of them. Then we have 18, right? These are all multiples which are common to both the tables. But the smallest one among them is 6. So LCM, the least common multiple, that is the first number which appears in the multiplication table of the two numbers, is the least common multiple, that is equal to 6. So let us see how we calculate the numbers. So if somebody asks me to calculate the value of the LCM of 12 and 14, I take 12 and 14 together and start division by the first prime, that is 2. 2 6 are 12, 2 7s are 14. 2 3s are 6, 7 cannot be divided, keep it as it is. 3 1s are 3, 7 cannot be divided, keep it as it is. 7 1s are 7 1s are, right? So 2 2s are 4, 4 3s are 12, and 12 multiplied by 7 gives me the final answer. So 12 multiplied by 7 should give me the answer, and that is the LCM for both the digits combined, which is 84. For 15 and 30, 15 and 30. So 2 15 cannot be divided, 2 15s are 30, 3 5s are 15, 3 5s are 15, 5 1s are 5, 5 1s are 5. So 5 3s are 15, 15 2s are 30. The answer to the LCM value of both the given numbers is equal to 30. So 30 is the answer as the LCM. Similarly, to find the LCM of 16 and 25, 16 and 25. So by division, 2 8s are 16, cannot be divided. 2 4s are 8, cannot be divided. 2 2s are 4, cannot be divided. 2 1s are 2, cannot be divided. 5 1 as it is, 5 5s are 25, 5 1 as it is, 5 1s are 5. So 5 5s are 25, 25 2s are 50, 50 2s are 100, 100 2s are 200, and so on. So the final answer as to what is the LCM of both these numbers combined is 400. So find out the LCM of 40 and 50, and you should get answer as 200. The same technique is used to calculate the LCM of three numbers. So for 12, 15, and 30, I start with 2. 2 6 are 12, 15 as it is, 2 15s are 30. 2 3s are 6, 15 remain as it is. 3 1s are 3, 3 5s are 15, 3 5s are 15. 5 1 as it is, 5 1s are 1s are. So 5 3s are 15, 15 2s are 30, 30 2s are 60. So the LCM of these numbers is 60. Can you give me the value of the LCM of 8, 24, and 40? If you have calculated it right, the answer should come out to be 120. So here are some important results. The HCF we find out will be the least of all the numbers. So if I'm wanting to find out the HCF of, let us say, 12 and 14, the HCF is 2, which is less than the smallest number in the group. Similarly, for 12, 24, and 36, the HCF is 12, which is equal to the smallest number in the group. So the HCF for a set of numbers can never be more than the smallest number of the group. Similarly, the LCM will be greater than the smallest number in the group. So for, let us say, 12 and 15, the LCM is equal to 60, which is larger than the largest number of the group. For the numbers 30, 60, and 120, the least common multiple is 120, which is equal to the largest number of the group. So the property is LCM will be greater than or equal to the greatest of all the numbers in the group. Now, let us take two numbers 4 and 6, right? So the HCF of 4 and 6 is 2, and the LCM of 4 and 6 is 12. And also 4 multiplied by 6 is equal to 2 multiplied by 12. So the product of any two numbers is equal to the product of their HCF and their LCM. If you want to find out the HCF of fractions, you take the HCF of the numerators and divide it by the LCM of the denominators. And similarly, to find out the LCM of fractions, you take the LCM of the numerators and divide it by the HCF of the denominators. Let me show you an examples of the last two properties. So if I want to find out the HCF and LCM of, let us say, two by 3, 3 by 4, and 4 by 5. Then, to find the HCF, I take the HCF of the numerators 2, 3, and 4 and divide it by the LCM of the denominators 3, 4, and 5. So HCF of 2, 3, and 4 is 1. LCM of 3, 4, and 5 is 60. So the value of the HCF of these numbers is 1 by 60. To find the LCM of the three numbers, I take the LCM of the numbers on top, that is 2, 3, 4, and divide it by the HCF of the numbers at the bottom, that is 3, 4, and 5. So the LCM of 2, 3, and 4 is equal to 12, and HCF of 3, 4, and 5 is equal to 1. So the value of the HCF is 1 by 60 and the LCM is 12 by 1. Can you quickly calculate the value of the HCF and LCM of 3 by 10, 6 by 11, and 9 by 2? If you did your calculations right, the HCF should be 3 divided by 110 and LCM is 18 divided by 1. So that is pretty much the basic concepts of HCM and LCM. Let's take a look at a couple of examples using these things. So, what is the largest size of a square tile to cover a room that is 5.5 meters wide and 8.5 meters long? But the condition is that the minimum number of tiles possible must be used without breaking them. So for this, let's understand a basic concept. Supposing I have a room of dimensions 4 by 6. Now, if I want to completely cover it with square tiles, I can use tiles which are of dimension 1 by 1. So, if I've covered this room with tiles which are of dimension 1 by 1, then the total number of tiles which I require is 24, right? However, I can also cover the same room of dimensions 4 by 6 by using tiles which are of dimension 2 by 2, right? I can use 2 by 2 square tiles and then the total number of tiles which I'll require is only 6. So, the larger the size of the tile, the lesser the number of tiles. So, for square, both sides must be 6 must be split into that number, 4 must also be split into that number. So I require the highest value of the number which is common to both. That means the size of the tile can be found out by finding out the HCF of the numbers. So to find out the HCF of 5.5 and 8.5 means the value 0.5. So the size of the tile which can be covering this room will be 50 centimeters multiplied by 50 centimeters or 0.5 meters into 0.5 meters, right? So whenever you have to find out the number of tiles which is to be covering the room and the least number, you find out the HCF. So the size of tiles will be given by the value. Now why did I take 50 to 50? 50 is the HCF, that is one side. So the area of this tile will be 50 multiplied by 50. Chalo. Now, what is the least number of square tiles required? So this is the same problem, right? To find out the least number of square tiles, I need the largest size of the tiles. So the highest common factor for 325 and 425 is equal to 25, right? So the size of the tiles which can fit the room, the largest size will be 25 by 25. So to find the number of tiles, I divide the total area of the room by the area of tiles, right? So this will give me 13 multiplied by 17. So the total number of tiles is 13 multiplied by 17, that is 221 tiles. So why did I take 25 into 25? Because 25 is the side of one tile. So the area of the tile is length into breadth. So 25 into 25. So area of the room divided by area of one tile is the total number of tiles. Chalo. Now, find the greatest number which on dividing 50 and 58 leaves remainders 1 and 2 respectively. So when 50 is divided by the number, it leaves the remainder 1. That means 50 is one excess of the multiple. So the exact number which is divided is 50 minus 1, that is 49. Similarly, when 58 is divided, 2 is excess. So I subtract 2. That means the number which is being divided is actually 56. So the greatest or the highest common number for 49 and 56 is simply 7. So the greatest number, the required number is nothing but the HCF of 50 minus 1 and 58 minus 2. That is 49 and 56. So the answer is equal to 7. So to find the greatest number which dividing 1657 and 2037 leaves a remainder 6 and 5. So if 1657 is 6 excess, then it is the number is 1657 minus 6 and 2037 minus 5. Right, I remove the excesses. So that means I need to find the HCF of 1651 and 2032. And if you do your calculations correctly, the answer will be 127. The largest number which divides 62, 132 and 237 to leave the same remainder. Now what is the remainder? I don't know. So the technique here is you take two of the numbers together at a time. You take two of the numbers together and take two of the numbers together at a time and find the difference of the numbers. So 132 minus 62, you find the differences of the numbers, so that is 70. Then you take 237 and 62, the difference of the numbers is 175. You take 237 and 132, the difference of the numbers is 105. So now if you find out the HCF of the three numbers 70, 175 and 105, then you will get the number which satisfies the condition. So from the given options, the answer is equal to 35. So these are some of the type of problems which can be asked, which can use the basic concepts of HCM and LCM to solve them.